Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we're going to talk about Microsoft Azure table storage in more detail. We're going to start with the things that we already know and then build on that knowledge. So let's begin with the things that we do know. We talked previously about how storage tables are organized. We've already looked at how to create a storage account. We noted that within a given account you can have multiple tables. So as you can see from this diagram, that you can have a table called customers and a table called wine photos. And then finally, inside of each table there are a series of entities, not rows, but rather entities. And we talked about this before, how a given entity can have up to 255 properties, and those properties don't have to match from one instance or one entity to the next instance or the next entity within the same table. They probably should, and they're going to have some common fields like a partition key and a row key and a timestamp, things of that nature. But the other 252 properties can be completely different, although that's not all that practical most of the time. However, that does bring us to what we saw in a previous module when we were looking at the Azure tools for Visual Studio. We looked at a table in the main area, and it was represented kind of like this, where we have two entities that have the same properties, the same name value pairs, not just the partition key, row key, and timestamp, but also email, phone number. However, there's a third entity that has a different property stored, which is the hobbies, where programming and reading value is stored. Now, this would imply in a relational database management system that there's wasted space, but that's not the case. That's just how it's represented in a tabular format. Also, the challenge with viewing data in this tabular format is that it does force you, or it leads your mind to think about tables, Azure storage tables, in the same way that you would think about relational database management system tables. However, that's not the case. Azure storage tables don't have the notion of constraints and columns and relationships and things of that nature. So as we kind of move through this material, and talk about the differences between the two, there's actually a very good article. You can see that there's a shortcut there on screen. Let me find it really quick here. Yeah, there it is. Azure Table Storage and Windows Azure SQL Database compared and contrasted. And so it does talk about the differences and why you might select one over the other. So I highly recommend that you read this to get a more full understanding from, beyond what I'm saying in this particular module. Now let me call your attention to one practical matter that will kind of set up, in my mind, what the practical difference is between the two. If you scroll all the way down to this section called Capacity and Quotas, you can see that in Azure Table Storage, the maximum row, or rather the maximum entity size, is 1 megabyte. So you can have 255 properties, but when you add up all of the data inside of those properties, they can't exceed 1 megabyte. On the other hand, in an Azure SQL database, each row could contain up to 2 gigabytes. So you could include like blobs and very long strings and things of that nature inside of a row inside of an Azure SQL database. So at first glance, you would say, okay, well that makes sense. You would always choose Azure SQL because you could put almost an unlimited amount of information in every single row. However, take a look at the very next line, which is the maximum data size. Any given table can be 200 terabytes in Azure Table Storage, whereas in Azure SQL Database, the whole database can only be 150 gigabytes. And so that should start helping us to understand the difference in the purpose of these two technologies. Let's pop back over here to our slides. And I guess what I'd really like to kind of emphasize in this is that you can't design Azure storage tables using a relational database mindset. The theories that Codd put forth, normalization, the normal forms, these two technologies serve a very different purpose. So applying that thought process to this new technology is going to lead you down some dead ends. Now, Obviously, from what I said in a previous module, you can mix and match these. So for example, we're going to talk about an audit table in just a moment. And an audit table might contain audit events within a given software system for every user in the system. Well, we might use Azure Storage Tables to store the audit data. However, the specific information about each user we might choose to store inside of a relational database management system, and then as long as they have the same primary key, I guess you can say, that represents a single entity, a single user in the system, well, you can create kind of a virtual relationship between the data, even though it's in two different data stores, even though that relationship is not enforced by the software itself. Okay, so then the question comes up then, why would you use, in what scenarios would you use Azure Storage Tables? Well, again, I want to emphasize that when you think about 200 terabytes of data, you're thinking about a massive amount of storage. So I would recommend that you use Azure Storage Tables for things that like write and forget operations, for data persistence where we just need to write once and then kind of forget about the data. Yes, we can update the data and delete the data, but it's probably better to just write it and forget about it. And so things like logging events, for example, going back to that audit table example. So let's talk about an entity itself. If an entity is like a row, if an entity is the smallest unit that we're going to store within an Azure Storage Table, then what comprises an entity? Well, we said that there are 255 properties, but there are several required properties, such as the partition key, and a row key, and a timestamp. And then there's also something called an E tag that can be used for optimistic concurrency, and it addresses that scenario where two people are editing the same record at the same time. Which edit wins when they both read at the same time, then one person makes an edit, and now this person has a dirty read. It's no longer in sync with what's actually in the data store, and so when they go to save it, the E tag will let the API, the client library, know that you're about to overwrite a dirty read, and they can stop that and ask the second user and say, hey, data has changed out from under you since the last time that you read this record. Are you sure you want to save and overwrite the previous changes from just a moment ago by another user? All right, that sort of situation. But let's not worry about that. We're focused mainly on the partition key and the row key. And so, kind of explaining what the role of the partition key is, you got to step back a moment and talk again about how to design and structure Azure Table Storage. And so, as we talked about in a previous module, NoSQL databases are good at horizontal scaling, and they do that based on sharding. And so I never really explained what sharding was, but I've got a good definition for you here. And I think I pulled this from Wikipedia, I can't recall, but basically sharding is a database term that refers to the physical partitioning of very logical data stores. So basically you split a large database into shards, or rather into smaller, faster, more easily managed parts. And so you can do this in SQL Server in order to spread a very large database onto multiple hard drives or across multiple SANs. However, Azure Table Storage tables are sharded by default right from the get-go based on a special property of each entity, and that special property is a partition key. And so you might shard based on, for example, a user. You might shard based on an event, but basically you're going to shard, or you're going to create your partition key based on the most significant segmentation within the table. So in this particular case, we're going to come back to that little example I described of an audit table for a software system. Maybe it's a financial software system, and what you need to do is make sure that every one of the employees within your organization are not trying to manipulate the system in some way to give their relatives free money or free shares of stock or whatever the case might be. So you want to record all of the actions that every user takes in the system, and in that particular case, if you may never need to recall that data or look at that data, but if you suspect there's some fraud going on, then you probably want to pull all of the audit records for a single user of the system. In that particular case, we would partition or shard the data based on each user. So we would use something like a user identifier. It could be the user's name, probably more likely will be some identification number. It could be in the United States a social security number, which should be unique to every citizen in the United States. It could be just a GUID or a random key that's generated, but that represents a single user within the system. And now you would have multiple entities within the table that all share the same partition key. Their only difference is the row key and then the properties that are saved for that particular entity. And so a row key is something that uniquely identifies a given entity. It could be, for example, an audit event. So if there were 100 actions taken by Bob Tabor in the software system, we would see 100 entities inside of the table, each one with the same partition key of Bob Tabor or user ID 12345, but they would each have a different row key. Okay. Now, again, I want to emphasize that you partition based on the most significant segmentation inside of the table. Suppose we're not using audit to ensure that there's no fraud in the system. Perhaps we're doing a usability study on the software to see how many times each feature of a given software system is being used. In that case, the most significant segmentation might be the event ID, and we don't really care so much about who actually performed that event. We're just looking for the raw statistics on which features in our software are being used most frequently and how they're being used. In that particular case, we might make the partition key the event or some event ID that represents a specific action inside of our software. And then we might make the row key, again, maybe some GUID. It could be a combination of the user ID and a timestamp, something along those lines. Okay, so hopefully that helps you understand the way that you would go about designing table storage. Now let's talk about some of the practical ways that you'll actually come in contact with Azure Storage tables from within inside applications that you're writing. And so as a C# or .NET developer, your main point of contact will be through a special client library called the Azure Storage Client Library. As I record this video, the current version is 4.3.0. However, when you install the Azure SDK 2.5, it does not have the most recent version of the Azure Storage Client Library. So as I suggested a couple of modules ago, typically what you're going to want to do is go out and use the NuGet feature inside of Visual Studio to not only update the current version of the library itself, but then also all of the dependencies that it has on multiple libraries, maybe for dealing with JSON and things of that nature, or serialization, things like that. But again, the storage client library is only a wrapper around this RESTful HTTP management API that we talked about at the very beginning of this series of courses when we talked about the different ways that you would come in contact with Azure. We said that for every action, for every offering inside of Azure, that there is going to be some HTTP-based RESTful API that will allow us to perform an action. And so these client libraries are purely just classes that make calls out to the endpoint using this RESTful HTTP API syntax. And more about that in just a moment. So let's talk about how you'll come in contact and how you'll actually interact with Azure tables. First of all, you're going to need to create a connection to a storage account. So there's an object or a class inside of the client library that deals with this connection. You pass it a connection string. It knows where to look to find now your storage account. And then you create a connection to a table, or alternatively, you actually create a new table in the account if it doesn't already exist. And now you're either going to create, read, update, or delete entities inside of that table. So let's talk about inserting entities first of all. You can insert entities one by one, or you can perform a batch insertion. Typically, whenever you're dealing with Azure, writes or reads, or any operation for that matter, you want to work in batch because every transaction is going to cost you a fraction of a penny. I think it was like 3.5 36 1,000ths of a cent per 100,000 transactions. And you might say, well, that doesn't sound like a whole lot, but if you have a very popular application, it can add up. So typically, as a best practice, you want to do everything in batches. However, you can insert records one at a time if that's what you want to do. Now, what are you going to insert into the table? Well, typically what you'll wind up doing is that you're going to create a plain old CLR object, some entity or some domain object or domain class inside of your system that represents something about your system. So it could be a user, it could be a product, it could be some activity in the system. And when you create those plain old CLR objects that represent domain objects in your system, they have to inherit from a table entity class in order to be serialized for persistence into the Azure storage table. So let me show you a demonstration of this. If you take a look, first of all, here, let me go here. The source code that I'm pulling from for this example is, an amalgamation of several little code examples in this great documentation here on Microsoft Azure's own website. Here's the URL on screen to get to this page. You'll see that I've already stolen one of their little diagrams here earlier in the PowerPoint presentation. But if you scroll down, there's some information about creating a connection string and then actually starting the connection process, creating a table, adding an entity to a table, and so on. Okay, so let's talk about adding that entity, and let's look at this example, which I pretty much, again, stole this code from that web page we just looked at. What we're going to do is create new instances of a customer entity, passing in the last name and the first name. This will become the partition key, and this will become the row key for each row in our persons. Oh, actually, the table is called table storage simple. All right, and so we're going to insert these two in batch into our new table. Now, what is this customer entity? Well, it's a plain old CLR object that we have defined here. It has two public properties, email and phone number. And then it also has a constructor that allows us to pass in a last name and first name that will set to the partition key and the row key. These two properties are inherited whenever we inherit from the table entity. And so by inheriting from table entity, now we can actually perform these insertions. Furthermore, whenever we go to query entities out of the Azure Storage table, we'll pass that in as a generic type to the table query object, which we'll talk about in just a moment. But I guess the big takeaway from this is that whatever you want to persist into a table, if you're going to have a representation of that inside of your C# application, you're going to need to inherit from table entity class. All right, so let's move on from here. So we've inserted entities, but now we're going to want to potentially perform some other type of command, whether that be an update, a delete, or we want to retrieve one or more entities or retrieve a filtered list of one or more entities from the table. And so let's go back to our example here and scroll up a little bit. And we can see that in order to perform that a simple query to return all of the customer entities where the partition key equals Smith, we would create a link query like so. Now this is using method syntax. You can also use the link query syntax. I'm not as comfortable with that. I prefer the method syntax. Most of the examples you'll see use method syntax. I recommend that you learn the method syntax personally. But at any rate, we are creating a new instance of table query of type customer entity. And we're calling a helper method, the where method, on that new table query object. Inside of the where, we're going to create a filter condition. So we're going to search where partition key is equal to Smith. And then once we have that table query object, we're going to pass it in to our table, the object that represents the table that we're connected to in storage, and then call the execute query method passing in that query object. All right, so the question comes up is, what do we get from this generate filter condition, from this where clause? I mean, what's going on here? Why do we have to use this crazy syntax in order to do something as easy as that we would get in like a transact statement where clause? So I could do something like where partition key equals Smith, Why do I have to go through this convoluted way of working with it? Well, what I did was, just for fun, as you can see here in line number 48 and 49, I am actually writing out whatever we get generated from that generate filter condition, passing in the same partition key, query comparison dot equal, and then Smith. So let's run the application and let's see what gets output there. And well, let's see. Yeah, okay. I've already got data in the database with that. Let's see. Let me go here to the Server Explorer. I need to go to table storage simple. I need to delete these rows out. So quick review on how to do that if you run into these kind of issues while you're testing. All right, so we should be good to go there. Let's close that out and let's rerun the application now. All right, let me pull this over to the recording area. And you can see that here at the very top, that table.query.generate filter condition, it spits out the string partition key EQ single quote unquote Smith. All right, and that might look like some odd syntax, but that's essentially what's being passed to this where method here. We're just passing in a string. So we could really just eliminate all of this and just pass in that string that was generated if we wanted to. And to kind of show you where this comes from, take a look on screen right now. There's a URL to this web page, Querying Tables and Entities. And you can see here that there are a number of supported query comparison operators. We've already used equal, but there's also greater than or equal, less than or equal, not equal. And then there's also some operators that can join comparison operators together or expressions together, so and, not, and or. And why this is significant is that what's being created behind the scenes is a call into that management API, that HTTP-based RESTful API. And that really what's being executed by the client library is just a call out to a URI. And that URI is defined as an OData filter expression. What is OData? Let me get back to my... So OData is a RESTful data access protocol that was initially defined by Microsoft. The protocol enables the creation and consumption of RESTful APIs which allow resources identified using URLs and defined in a data model to be published and edited by web clients using simple HTTP messages. So whenever we're looking at that whole Azure Management API, that RESTful API, it's all based on this specification of OData, which defines how do you actually create a URL that is that follows the standard. And one of the substandards, I guess you can say, one of the little parts of this standardization is the filtering syntax. And you can see here in section 4.5 on that web page that I give you the link to that we have these operators EQ, GT, LT, like we looked at a moment ago, and then what's actually spit out there as a URI that's then sent to the Azure Management Service endpoint. So you can be very expressive in the filtering of the records, or rather the entities that you bring back. But what's really going on behind the scenes is that it's constructing this URL that's passing to Azure on your behalf. Okay? I realize that was a little bit of the under the hood look of what's going on here, but if you really want to understand how that Service Management API works, you probably want to spend a little time learning about the OData specification. This would also help you to design your own RESTful APIs if you want to do something similar for your own applications within your own organization. All right, so back to the matter at hand. Okay, finally what I want to do is talk about some other scenarios that we're going to cover in a couple of modules from now. We said that any given entity within a table can have its own set of properties, and they don't have to be the same set of properties as other entities inside of that same table. And so there's a very dynamic, loosey-goosey, semi-structured format to the data that we store in our tables. That's great. That's very flexible. However, how does that work whenever we're working with our own entity objects, our own what I call domain objects inside of our system, where we want to persist these objects and then read them back out and then utilize them inside of our application? How do we work with the dynamic nature of the properties on these entities? Well, I'm going to demonstrate two different ways in an upcoming module to work with those. And then finally, what I want to talk about is that there is a limit to the number of entities that you can bring back in a single request. There is actually a limit of 1,000 entities that you can retrieve. Now, in Transact SQL, using SQL Server, there's no limit to the number of rows that you can bring back. However, in order to make the Azure storage tables more performant, they cap out the number of entities that you can retrieve. And so then you might be asking yourself, well, then how do I get more than 1,000? What if I have 5,000 different entities that I want to retrieve? Well, you can write a query in such a way that it will give you back what's called a continuation token. And that token is like a bookmark. This is where I left off in the query last time. So if you want me to perform this query and start back from where I left off on, just give me that query again, give me the continuation token, and I'll give you the next 1,000 entities. And we'll demonstrate how to do that in an upcoming module as well. Hopefully this was helpful to get your mind around table storage, how it can be used, and what scenarios does it make sense, some of the particulars about using it inside your own applications, what's really going on under the hood with the OData specification and the filter expressions that are passed in a URI, and then some preview of what we're going to talk about here in the next couple of modules. All right, so let's go ahead and start digging deep into the code itself. We'll do that beginning in the next module. We'll see you there. Thank you.